transfer function with two components. The purpose of this work is to observe the way in which the transfer functions are obtained from some differential equations given. In this presentation, the development of the solution is shown by the Laplace transform technique. This development illustrates the application and usefulness of differential and integral calculus in the field of physical phenomena such as the transfer of energy in an electrical circuit. These three linear differential equations form the basis of the analysis of the transfer functions, each of which can be solved by simple integration with which the desired result is obtained. However, in this case, they serve as a basis for reviewing the application of the method Laplace transforms. In this graph, it is observed how the two transfer functions are related. In both cases, the component functions are indicated by x and y. The transfer function represents a relationship of proportionality. When they are equal, transfer is 100%. If the first is higher, there will be an accumulation. Depending on the type of functions, there will be times of accumulation and other of efficiency in the output. For the first equation in the Laplace transform, of both sides equality applies. On the left side, the formula for the derivative, and on the right side, the linearity property, and the results of the transform table is used. Then a transform is cleared on the left side and complete the expressions on the right to apply the inverse transform using the tables and getting the result, which can easily check the referral. The second equation follows the same sequence as described above. The rule to transform a derivative with zero initial condition applies. L is cleared and the inverse transform is applied. To apply the inverse transform must become the last expression by partial fractions and applying the linearity property of the inverse transform. In deriving the result is checked for validity. The third differential equation applies again and the sequence of activities for the solution. The formula of the transfer function relates the output of the system with the input by means of a proportion. Substituting the results, we have the two transfer functions. To develop graphical and tabular for each case can be seen when there is a deficit or surplus in the flow of energy. Appropriate references are present to check the background of the concepts used in this paper.